We're going to review very quickly the properties of exponents for our work with exponential functions. Here we have two functions that are being multiplied by each other. These are functions or expressions, but since we do most of our work with functions, that's how we're going to use these properties. So we have the product of two things. If they are exponential expressions or functions, when we multiply the same base, we add the exponents. So if I have a to the m times a to the n, that is equivalent, the same as, can be replaced by a to the sum m plus n. We have a habit in lower mathematics of just teaching it in one direction, but I want you to understand you're going to use it just as often in the opposite direction. If you have an expression that is the base 3 raised to the quantity x minus 2, it may be helpful for you to recognize or use that. It may be helpful to clean up your expression and use this property in this direction. So make sure you understand that, again, as I've said over and over in prior lessons, that is a biconditional statement. It works in both directions, and you're going to be responsible for knowing that in both directions, as with all of these properties. When we raise a power to a power, this is a to the m, and the entire expression is raised to the power of n. When we raise a power to a power, we multiply the exponents. Again, if we had 3 to the negative 2x, that could equivalently be written as the quantity 3 to the negative 2 raised to the x power, and equivalently written as 3 to the x power raised to the power of negative 2, because we multiply the exponents and multiplication is commutative. When we multiply two different bases and those bases are raised to a common power, the power will break up over the operation of multiplication. Powers do not break up over the operation of addition or subtraction. Be very careful. But they do break up over the operation of multiplication and division. So if I have a quotient and the entire quotient is raised to a power, then the power breaks up over the operation of division. Again, they work in both directions. Whichever direction you need to go is the property that you're going to use. When we have a negative exponent, when we cross the fraction line, whatever we do, we cross the fraction line, we change the sign. So additionally, if I have 1 over a base to a negative exponent, I can cross that fraction line, and I'm going to change that negative sign on my exponent. Those are equivalent statements. Know them in both directions. Because square root can be written as a fractional exponent, it follows the rule that we just explored on the previous slide. Exponents break up over division. So that makes this a true statement if we went in that direction, because this is equivalent to the square root of a over the square root of b. And again, because it is a fractional exponent, it follows the exponential rule, where exponents do break up over multiplication. That is equivalent to this statement. Again, you're responsible for knowing those in both directions. When we have a fractional exponent, when our exponent is in rational form, when it's a fraction, we have a couple of choices. We know that the numerator is the exponent to the base. We have a base raised to the numerator in the fraction over the denominator in the fraction. The numerator is the exponent on the base. The denominator is the root of the entire expression. So we have our base raised to our power of m with a root of n. When we raise a power to a power, we multiply. That's why we get b to the m over n. So if we were going to write this as a root, it is the nth root of our base b raised to the m power. It is equivalent to say that is the nth root of b, all of which is raised to the nth power. Mth power. So make sure you know these in all directions. We're never sure which part of that property, which form of that property you're going to need to use and to apply. Let's review completing the square from Algebra 2. The first thing we want to do is get the quadratic equation in the form of ax squared plus bx equals c. Here's the form ax squared plus bx plus c equals 0. So step 1, we're going to subtract c from both sides. So I'm going to do that with my example. 3x squared minus 2x would have to equal a positive 1. The next thing that we want is we want the coefficient to our squared term to be 1. So I'm going to go through here and I'm going to divide each term by 3. That gives me a lead coefficient of 1. Now I have done everything in step 1 of the process. Step 2 of the process says take half of b, here's b, negative 2/3. I want 1/2 of that, and I'm going to square the whole thing. So my 2's cancel, and I wind up with negative 1/3 squared, which is a positive 1/9. And I'm going to add that value to both sides of my equation. So x squared minus 2/3 x plus 1/9 must equal 1/3 plus 1/9. I picked this equation up and added 1/9 to both sides. Now I want to factor the left-hand side, and it's going to be a perfect square trinomial. Something that when I add outside and inside, I get negative 2/3, and when I multiply the last two terms, I get a positive 1/9. So there's how the left side is going to factor. And then I want a sum, just one constant, on the right-hand side. And now I'm just going to use good algebra to solve step number 4. Well, I want to undo all the operations that are showing up here. So I undo squaring something by taking the square root of it. And if I have the square root of something squared, that result could give me the positive or the negative value that started out in here. So possibly one of the things that I see most often is students forget to include that plus or minus, because Since we're squaring what went on in there, it could have been a negative value. So don't forget that. This is a really big deal that costs students a lot of points that really shouldn't. So I have x minus 1/3 equals, and the square root of 4 is 2, the square root of 9 is 3. So it either equals a positive 2/3 or x minus 1/3 equals a negative 2/3. And since we're dealing with a quadratic equation, I shouldn't be surprised that I have two possible solutions to that quadratic equation. So here I'm going to add 1/3 to both sides, so x could be 1, or adding 1/3 to this side, x could be negative 1/3. So there are two possible solutions using completing the square.